so everyone knows. All right. Hello, everyone. We're here today for the IGIC Lunch and Learn, and today our presenter is Howard. He works for Hobu, a software engineering consultancy in Iowa City, and he's going to be talking about LiDAR and using LiDAR with open source software. I don't know a lot about it, which is one of the reasons I'm here, and I'm interested to see the different kinds of tools that we have available. Howard, is there anything you would like to also add about yourself?
I don't think so. I've been located. So my name's, again, Howard Butler. I have a consultancy in Iowa City. It started as just my one-man consultancy shop, and currently we have 3 employees in Iowa City and 1 in Peterborough, New Hampshire. And so we've been in Iowa City almost 15 years now. A long time ago, I went to Iowa State and did my degrees there. And our consultancy is focused on open source geospatial software, primarily in the LiDAR space, but a number of the open source tools that some of this audience might be familiar with, like GDAL and Proj and things like that, we've been very actively involved with in the development and putting them out. And our client base is primarily USGS, Army Corps of Engineers, and other organizations with really large LiDAR data management challenges. How to manage, petabyte scale LiDAR collections, and what are you supposed to do with them, and how do you get value out of them? And so that's what we have been doing.
Before you go too far there, Howard, I just want to reiterate that if people have questions, feel free to unmute yourself and just kind of butt in a little bit, because some of these are really deep topics and it might be hard to go back, 30 minutes previous. If you're not comfortable doing that or don't have a microphone available, go ahead and put it in the chat to everyone, and we'll make sure that your question gets asked. So sorry to interrupt, Howard. Continue, please.
No problem. Please interrupt me. I know everybody does Zoom calls all day long, so a voluntary Zoom call. Thanks for being here. And so here's kind of our agenda today. I'm not going to go particularly deep on any one of these topics, just kind of give a smattering overview of maybe what's going on with Iowa's LiDAR. Talk a little bit about streaming LiDAR and what that means, again, with the 3DEP data. Some of the open source tools we've developed, Poodle or PDAL and Entwine, to make some DEMs with that. Another open source tool called RichDem for doing some topo analysis that you might not have heard of before, and then talk about some upcoming technology. And I reach out to my contacts at USGS on 3DEP, and so I have some update on where data is at in the pipeline for Iowa. So we've been instrumental, Hobu has been instrumental in putting out open source tools for LiDAR data processing, and there's a number of them that are out there. We're well known for PDAL or Poodle, Entwine, which is the data organization tool. LazPy is a Python library for dealing with LAS files. There's also the LazZip library and LazTools toolkit that you might have heard of before. LazZip, of course, for compressing data, LazTools for doing processing workflows. And there's a number of other ones. Maybe an interesting one that you might not have heard of before, although maybe you've seen it, is something called Poetry, which is for visualizing large-scale point cloud collections in a browser. We're mostly concerned with talking about Poodle or PDAL today, but if you have any questions about some of these other things, I'd be happy to talk about them. Of course, for the audience benefit, maybe you know what 3DEP is, but 3DEP is 3D Elevation Program for the United States. Its goal is to do a 10-year capture, or capture all the LiDAR or not just LiDAR, high fidelity elevation data for the entire country on a 10-year period. I don't know that it's quite at that pace at this point, but there's been a furious data collection been going on recently. Iowa, was unique in that we were one of the first states to do a statewide capture in I think 2007 and 8 and 9, something like that. And so, we've been at the tail end of the list of the recapture because we already had lucky enough to have LiDAR data, but the software, the hardware sensors, everything has advanced quite a bit in the last 12 years plus. And so the ability to capture much higher quality data is available. The desire of 3DEP, is to provide multiple support for multiple uses. So that includes things like hydrology, simple mapping, disaster preparedness. You'll see people doing things like solar roof orientation planning or power line and infrastructure routing type activities. And so this data has lots and lots of uses. It's not always clear once you capture it what those uses might be, but it's a valuable resource for people to do stuff with. So Iowa's LiDAR, again, we're talking about aerial LiDAR, so LiDAR that was captured with some sort of airborne sensor. Predominantly it's the pre-3DEP statewide surface. So 3DEP was, I think, organized in 11 or 12 when it was actually organized as kind of a program. And so states were doing various data collections on their own or with partners. And before that time, there wasn't necessarily nationwide standards for what those data should be collected to and how they should be processed and what sort of criteria they needed to meet. And 3DEP organized and regularized that. So depending on what you're doing, that has some usefulness. Of course, any data is good data though when you need something. And so for Iowa's case, we have the pre-3DEP data, and it has been used for many things, and it's still quite useful, especially for doing things like change detection with new LiDAR if we can get it. There was a Homeland Security acquisition of Des Moines in 2011 or 12. It's kind of the city center and maybe the kind of the bounded 235 80 area plus some southeast of the city there. But it was a really high density collection, right? So it's a multiple times more dense than the statewide surface was. And so if you're doing urban environment stuff in Des Moines, or you want to do change detection, that might be useful to you. There's been a number of kind of special collections, bluff to bluff of Missouri River and bluff to bluff of Mississippi River, things like that, that have happened through various partnerships and groups. And then, just recently, USGS has started acquiring 3DEP data for Iowa again as part of its collection period. So Iowa has a whole bunch of LiDAR data coming in the next couple of years. So I guess where to get it in order of simplicity. So I think one of the easiest ways to get LiDAR data, especially to just simply look at it, is the USGS streaming website that we developed at usgs.entwine.io. And that is an Amazon public data set of almost all of the USGS 3DEP data. It's freely available, zero cost. You can write software against it. You can download data or visualize data in your browser. Open Topography is another great place to access Iowa's LiDAR. So Open Topography connects to this USGS data set, but it provides tools for you to do things like elevation modeling, processing, filtering, activities like that. And so you can create a login in Open Topography and participate there. USGS has something called Earth Explorer, which is kind of a bulk access. So if you're collecting data for some reason, you wanted to get a large area of LiDAR data, you might use Earth Explorer to go fetch a bunch of tiles. And same with GeoTree, you can get the data there as well. But then it's your responsibility to do kind of the management of all of that data and have to deal with whatever the challenges of dealing with, at least for Iowa's pre-3DEP data collection. It's about 1.7 terabytes of LAZ. So usgs.entwine.io, this is developed with a technology that we constructed over the past few years called Entwine. And what Entwine is to take a really large collection, a statewide collection of LiDAR data, and make it available on the cloud for anybody to access, and allow software to incrementally access that data for things like visualization or processing small windows. So if you wanted to do some sort of adaptive tiling scheme where you were panning across a large area and processing small tiles to a specified resolution, Entwine is perfect for that. Entwine has grown up in cloud environments. It's expected that you're operating your data management, your data processing in cloud environments, and your data organization has to live within those constraints, whether it's how they access the data, how much memory and how much storage they can use while they're accessing the data, and so on. And so Entwine provides capability to do that. The USGS public data set, which lives at this URL, is supported by Amazon and for free to the community, and it provides about 31 trillion LiDAR points of corresponding to about 200 terabytes of data that's available online. So USGS has been pushing data as it goes through its data verification pipeline to this website so that anybody can access the data and use it this way at zero cost. It's been increasing pretty much weekly as the data goes through their quality control in their systems. And the nice thing about the website is it provides like browser-based visualization. So if you just wanted to quickly look at data or make some determination whether it's suitable for what you're trying to do, but it's also a really significant data service that software can access and do things with. So here is Iowa's 170 billion point pre-3DEP collection available on this website. And you can adjust its visualization, do things like intensity, and you can do all sorts of stuff with the Poetry software that's available there. But the ability to provide that as one single contiguous data service, has a lot of benefits to software wanting to do things at statewide or national scale, and this is the tooling that they can use to do that. So go to the website, there's a little search box there, which you can kind of filter by, there's about 1,700 different collects in the country at this point. So you kind of filter them by name if you wanted and visualize them with different tools. And then that EPT link there is how you get access to the data service. So it'd be like, you could think of it like a WMS URL or WFS URL if you've done those kinds of things. So Poodle, or Point Data Abstraction Library, is a software open source software toolkit that we developed for doing processing of LiDAR data, organization of LiDAR data, exploitation of LiDAR data. Poodle's kind of different than some of the other toolkits that are available, like you may have heard of white box tools or LAS tools. The way I tend to describe Poodle is you would use Poodle to make LAS tools, or you would use Poodle to make white box tools. And so instead of like defined workflows for doing various LiDAR and point cloud data processing tasks, Poodle provides a bunch of Lego bricks to build your own castle. And it's kind of on you to construct that however you need, depending on your data and whatever your data processing challenges are. But it provides a number of categories of functionality. So simple things like, or expected things like reading data, right? We need to read and write LAS data commonly, or this Entwine point tile stuff. Maybe we want to rasterize data to a TIFF or something, which we'll do in the talk a little bit later. We want to filter data for outliers and do something with them, or cut data by crop data by a polygon because we're only care about a particular window. Or we want to exploit those data in some way, like turn them into a mesh or smooth them, or extract only the ground points out of a data set. And so users of Poodle can construct this capability with something called a pipeline. And a pipeline is a series of stages that are organized in kind of a processing graph. And so you write a little JSON document that says, we're going to read file called a.las and we're going to reproject it, but b.las is already reprojected for us, so we're not going to reproject that one. Combine them together and output them into a TIFF. And so again, Poodle is about constructing these pipelines and organizing your ability to do data processing and point cloud processing tasks. It doesn't provide canned workflows for things like, oh, I want to do LAS classification or something like that. There are tools out there for doing that. Poodle allows you to build a LAS classifier, but it doesn't provide one, and that's kind of the distinction. So the scenario we're going to show today is just a simple urbanization scenario. It's going to take advantage of the newly acquired 3DEP data that's available for, I think it's South Central Iowa, that was just released this past spring. I took a small patch in Southwest Des Moines where some urbanization was going on. We're just going to make some terrain models and do a simple diff, right? So kind of a sort of basic scenario for LiDAR data. First step, go get our essentially our service URLs and copy those for the EPT collections that correspond to those, right? So we, again, think of those like a WMS URL or a WFS URL, where that's the service endpoint that software would interact with. And so again, a document that describes how processing happens in Poodle is a JSON document. And the reason for that is so that it's convenient for developer tools, of course, to do things with it. Its expected audience is software developers of some kind, although it's not too difficult to construct these JSON documents yourself. There's also some command line utilities to help you do this as well. The important thing, though, is to define essentially where is that endpoint or URL. In this case, it's called a file name because that's a Poodle convention, but where we're going to reach and access that data. And then we're going to give it a bounds at the top item there. And so Entwine allows a software client to filter the data for both a geographic range very quickly because the data are broken up, and for a hierarchical depth, right? So you can select data for a resolution. And so if you wanted to do things across, at 20-meter resolution over the entire state, you can access the data pretty quickly to do that with EPT. Or if you wanted to, in our case, we're going to look at this tiny little window in Southwest Des Moines where we're looking at this urbanization. We're going to select all of the data in this window, but the software is going to take care of figuring out, which points to select, which tiles to read, and all of that stuff. We don't have to worry about any of that. Another capability in Poodle that would, is pretty common and commonly desired is to, hey, it's LiDAR data interacts with the vegetation, it interacts with the environment. I don't care about any of that. I just want, a ground surface, and give me the best ground surface that you can. So one of the capabilities that's available in Poodle is something called SMRF, or simple morphological filters, which was a method developed by Thomas Pingle. And it works really well in Iowa, which is, not particularly mountainous terrain. And Poodle has an implementation that is pretty quick for doing that. So in that pipeline that we're constructing, after we read that data with Entwine, Poodle is going to apply this simple morphological filter to the data, and not use the ground. So sometimes data has ground classifications on it, and sometimes they're good, and sometimes they aren't. So being able to control that yourself and do it however you want potentially has some value to you, especially if you're trying to normalize things, for example. Then finally, we're going to just write the data back out to a TIFF. So, we want to do raster analysis here. We're not doing point cloud to point cloud comparisons for urbanization, although that's something you could do, but it's a little challenging. And so we're just simply going to write out a TIFF file. So Poodle has this a stage or a capability called writers.gdal, which will allow you to essentially write to any format that GDAL writes to. And so, TIFF, of course, is a common one. And we're going to set some options to do things like, hey, we want to tile it, or here's how you should compress that TIFF, and set our no data. And then what we're going to output then is essentially an inverse distance weighted elevation interpolation, right? So it's not very sophisticated, but the data are dense enough that, in many cases, that's going to work out quite well for you. We're going to specify a resolution, and then that window size is, how far to search for while we're doing this IDW operation. So here's our model. Just again, this rastered TIFF, showing it in Hillshade form here, just so it's easier to visualize. But of the 2010 data, and so in the kind of the western or southwestern portion of the scene, it's looking pretty flat. There looks like there's some sort of athletic fields there, and and mostly natural landscape or farm landscape that hasn't been developed, certainly as developed as kind of the northeast side of the scene. And then this capture that's happened in 2020, over in the western edge, we see, hopefully I'm not flipping back and forth, but we can see the landscape change quite a bit as urbanization is, adding buildings to the scene. It's moving dirt around to terraform things, and putting settling ponds in and things like that. So as the area is developed and for housing, we can see the scene certainly changing. So let me know if I'm flipping too quick or you can't kind of see that happening. So it's really nice in Iowa. We're going to be, we had early data, which we've had to live with, and it's whatever its warts have been for a while. But now that we're getting a recapture, we're going to be able to do some of these kind of change detection activities with our data as the new USGS data is acquired. So it should allow for some really interesting analysis beyond simple point cloud activities. Another capability that exists in PDAL, again, any pronunciation is fine here, but is height above ground or a canopy height model. So that's a commonly desired thing where we're going to take and construct a normalized height, vegetative height above ground. And so that, it's really useful in forestry type activities, but it also might be useful in ground or urban environments as well. And so this particular rendering is simply taking that 2020 model, extracting a height above ground surface. Again, that's done from the LiDAR data itself, where we take a terrain model, ground only terrain model, and then construct a difference of the LiDAR returns that are above that surface. And then again, we're rasterizing it to some depth or to some resolution and providing that. So, the brighter red here, the taller the trees are essentially. This can be really useful for visualization, can be really useful for doing biomass estimation, things like that. Anyway, this capability exists in PDAL and available for you to use today if you want to get the open source software and do things with it. Because we rasterize this data, of course, we can do a simple diff to kind of see what's going on. So, GDAL Calc is an open source software tool that you probably have available on your desktop in some way, whether through your commercial tools. If you're doing ArcGIS, I know that you can access the GDAL tools through a Conda environment there, or any other open source tool. And we're just simply taking these two rasters and subtracting them, and we can see, where in that southwest again area where dirt was moved around as the landscape was terraformed and developed, right? So developing settling ponds and moving things around. So some was lifted and some was set down. So, expected and very interesting sort of patterns that might be happening to the landscape, but you can write software to extract and hunt for this stuff. Another open source tool that's available, has been for a while, it's not particularly well known, is something called RichDem. So there's a software engineer up at the University of Minnesota, and he developed this library for doing flow metrics, depression, breaching, flow accumulation type activities. And it's really fast. It's available in Python and C++. And so if you're a Python user, you can take these TIFFs that we've written and do simple flow accumulation activities with them. You of course have these tools available to you in many other places, right? You have them available to you in GRASS, you have them available to you in ArcGIS, you have them available to you in QGIS, but this is just another toolkit that's available and can produce some interesting and maybe more sophisticated results for the different permutations that the methods support, like essentially how that flow moves through the landscape. Comparing our 2020 to 2010 collections, again, we're seeing this expected landscape change because of the development that's gone on in the area. And so we can see the housing development fill in and change how water's flowing across the landscape. And we can see all these settling ponds going in and stuff like that. Again, expected sort of activity. But these are some of the tools that you can use to extract and quantify this using the LiDAR data that's available in Iowa. so I was going to talk a little bit of, that's kind of the open source tooling stuff that's available right now. I guess I'll take a pause here. Does anybody have any questions or want me to go back and talk about a little more detail of how some of this stuff happened? I didn't know how deep this audience cared to go into this stuff. I mean, there are open source, there's tools, there's compiled binaries, there's documentation, there's a lot of stuff online to allow a user to kind of get started with this stuff. But I know it can be quite overwhelming to, if you just have a task you're trying to achieve and trying to figure out if a software can do that sort of thing for you. So, if anyone has any questions, feel free to reach out to me or, ask them right now. But these are some of the software capabilities are available. They're homegrown here in Iowa, and we've been working on them for quite a while. I'm gonna kind of switch gears here a little bit and talk about some technology that's on the horizon that we've been developing, and then talk a little bit about USGS stuff. Yeah, go ahead.
Well, we do have one question that came. Hi, Jim.
Hi.
From Jim G. And he asked, how well does the RichDem handle culverts?
So RichDem has a capability in it that he developed for doing cutting. So elevation model cutting. And so there's like two methods. One's like a fill cut method where it kind of fills it up and iteratively figures out the pour point. And there's one other method as well. So there is facility there for doing that. It also has some really nice multi-processing capability. So if you're running it on a big machine somewhere with lots of cores and stuff like that, it'll all split up and attack your data that way. So go check out the website and kind of look through what's available. It's kind of a unique and specialized toolkit. The reason why I kind of brought it up is it's one of the fastest flow accumulation constructors, and it's open source and available from Python, C++. So I was using it there, but yeah, there is some capability for doing depression cutting and culvert cutting through elevation models with that. I can't vouch for it, but I've certainly seen it. So, okay, so on to some technology development again. So we Hobu, our software team, we develop software for managing really large scale point cloud collections, and this is a really challenging task because the data are they're big, right? For all the sort of snarky descriptions of big data, I think LiDAR tends to qualify. And the data also need to be organized in a way that people can get value out of it, because their point cloud data tend to be what I call really fluffy, right? So, it's like a high resolution camera picture. You don't always need every pixel of that to be able to describe what was going on in the scene, and LiDAR tends to be that same way. But the organizations that are capturing all this LiDAR data, they spend a lot of money to acquire every pixel or every point of that LiDAR data, and they want to make sure that they have facility and capability to manage all of it. And so these two things are a little bit at odds, but constructing data formats, software tools, and software organization approaches to manage this data is a really can be a really challenging part of the story. And our involvement with partnering with USGS to show how they could use our technology to stream LiDAR data via entwined point tiles, has been really successful in terms of allowing people to use the data conveniently. So and of course, part of that is that's free access. So like just simply making it easier for people to get the data in bulk, but also allowing people to develop software tools that treat that data as a resource that they can access from anywhere over the internet, as opposed to an explicit sort of process that must go figure out which tiles to fetch and organize them in a way that the software can access, and kind of end-to-ending that entire story. So entwined point tiles is a technology, EPT or entwined point tiles is a technology that kind of assumes that you're operating in a cloud computing environment. And so there's a couple of really nice things that you can depend on if you're operating in a cloud computing environment. One is you can create lots and lots of files, and it really has zero cost to you to do that. There's really no distinction between having a terabyte as 1,000 files or a terabyte as one file. And in a cloud environment, that's great. On your laptop, though, that's a problem. 1,000 files on your problem is 1,000 things to manage, 1,000 things to that, one of them could get deleted, 1,000 things to send over a network, 1,000 things to copy to a USB drive. And so there exists a niche that isn't quite fully satisfied in the marketplace. And that's something that provides organized compressed point clouds. So LAZ files, as they're kind of typically made available in most data warehousing, or you go download USGS data, or you go download data from some other country, Germany, Denmark, whatever, you'll commonly find those LiDAR acquisitions available as bulk download as LAZ, but they're not organized in a way that software applications can ask for, hey, I only care about this particular window of the data, or I only care about the data to a certain depth, 20 meters or whatever the kind of threshold might be. And so we started developing this thing called COPC or COPIC. Again, programmers don't name things well or pronounce things well, but the idea is to provide an LAZ file that everybody's software who can read LAZ also optionally provides organization. And so the idea is to have this kind of EPT capability, but do it inside of LAZ files. And so this path and approach is not unique at all. If you've heard of something called COG, or Cloud Optimized GeoTIFF, which is starting to kind of take hold in our industry as a data access approach for raster data and data management approach for raster data, what COG did was kind of do the same thing, take an existing format that is already kind of widely supported, but reorient it in an opt-in way that allows applications to take advantage of its organization, whether it's remotely over kind of an HTTP server or locally as a file system on disk, but not disrupt any client who doesn't know this special organization stuff. Don't disrupt their ability to simply access the content. I just care about the points, And so COPIC is designed to do that. It takes advantage of the fact that, most of the industry has pretty good support for LAZ, and, many of the data warehouses and public data sources for aerial LiDAR data are using LAZ because LAZ provides, really great compression. It doesn't have any cost, and most of the tools have capability for it. So kind of the distinction between COPIC or COPC, and EPT is, so COPIC is again, it's a single LAZ file. It's not a bunch of exploded kind of little files that correspond to the resolution and the ranges of data that EPT does, right? But COPIC is only LAZ, right? So EPT, the entwined point tile approach, you can store data as compressed in many different ways. And so it's the access pattern that EPT defines that's really useful, but it doesn't have a pronouncement on how those data should be compressed or encoded. LAZ is one possibility in EPT, but there are many others, like Z standard, if you've heard of that, or just simply just zip and deflate. EPT also supports the idea of what we call interrupted insertion. So if you have say you were flying over an area, and on Tuesday you fly the eastern third of the collection, and then on Wednesday you want to fly the western or the middle third of the collection, you can have an EPT data source that is incrementally inserting each day's collection into it. COPIC and COPC isn't like that at all. Again, it's just a single LAZ file, right? It's organized as a single entity. But you would typically organize a COPIC or COPC file as just a normal tile, right? So maybe you've worked with Iowa's pre-3DEP data, and I think those are 2 by 1 kilometer tiles. And so one could imagine each of those 37,000 tiles be available as a COPIC file instead of simply an unorganized LAZ file. And software could do things like select for ranges or select partial data out of that very quickly and not have to essentially decompress all of that content simply to catch it or grab a little window or a small resolution bit of that data. EPT also supports this thing called add-ons, which is, so say you have a large collection of data like Iowa and it has classifications on it, and then you wrote some software to do your own classification scheme. EPT allows you to store that essentially as a sidecar incrementally as you go and access that data discretely. So as you're building up classification or as you're building up different derived products from a really large point cloud, EPT allows you to kind of store and access and manage those data as you go. Copic has no support for anything like that. Copic is a, you know, kind of what you would call a final format, right? So just like LAZ is kind of a final format, except it's unorganized, Copic is the same thing except organized for spatially accelerated access. So we're hoping that Copic is available as software tooling and a specification here, hopefully the end of the month or middle of next month. You know, we've been working on developing a specification for this out in public with open source developers who do a lot of LAZ. If this is something that interesting to you, please contact me after the presentation and I can connect you up with what's going on and you can follow along as we're building it. Finally, I have some 3-depth LiDAR updates. So again, we work with Usgs and I reached out to them to go, you know, hey, can you give us a status on where Iowa's LiDAR is at this point? You know, it's been in various stages of acquisition and quality control in the process. And so here's what they were able to send me in terms of statuses for various things. So, you know, Eastern Iowa is, you know, at pilot delivery or pilot data level, Western Iowa, of course, as well. There's one work unit that's been South Central 1, which is what I used for my little example here that's available for everyone to go access full density. You can access it from that website that I was talking about earlier, the usgs.entwine.io. It's also available on all the other resources that you can access LiDAR data from USGS. And then, of course, some status updates for some other ones. Looks like South Central is just waiting on corrections. And a bunch of North Central is still in the hopper doing corrections and getting close. I have no sort of idea on the timing of any of this. As an Iowa LiDAR user, of course, I want the data as consistent, as clean, and as fast as possible. And of course, none of those things are all achievable at once. But data's coming. We're about to get a bunch of LiDAR data for Iowa, and it's going to be really great. It'll be really nice data, a lot more resolute than the data that you might have worked with before for Iowa data, and hopefully it allows new capabilities and new analysis to happen that otherwise were, you know, extremely difficult. Some links here at the end. So if you want to install Poodle, you can go to pdal.io, and we have a bunch of kind of documentation on how to go grab this software and install it via Conda. If you're an ArcGIS user, you should be able to follow along with constructing a Conda environment within that and be able to access the software via that. So it works on Windows, works on OS X, works on Mac. It's available in all major Linux software packaging systems like Ubuntu and Red Hat. And, you know, it's available as typical open source software. Of course, everyone's familiar with 3-depth, but you can go to this, again, usgs.entwine.io. You can also use that to kind of watch data collection as it's been released, right? So after it goes through their QC process and they finally push it up, that map gets updated with a new footprint and the data is viewable right there. So that's about all I have for today. I'm happy to take any questions. Nobody interrupted me. You know, we can go back. We got plenty of time and talk about specific things, but thanks for hanging out with us, and hopefully you learned something about LiDAR that you didn't know before. So
Howard, this is Micah.
Yep.
I assume that's your license plate.
That is indeed my license plate.
That
yes.
is awesome. It's so geeky. I love it. Um, Jim G also piped up, and no, Jim, no one has. So apparently, our new USGS liaison is part of our group. Mitch.
Yes, this is Mitch Ferguson. Hello, everybody. So I am new to the USGS family, coming from the Fish and Wildlife Service. I was in charge of the data center for the National Wetlands Inventory, but have now come over to the USGS to be the liaison for Minnesota, Wisconsin, and Iowa. So if you need any, thank you. If you need any information, please reach out to me.
Yeah, he was the source of this info. So.
And Anina Rube asked, will IGIC send out an email when new LiDAR data is available? I would love to. How would we get that information? Because we would definitely disperse it. We just want to make sure that we get the right notifications.
And that's a question for Mitch.
Mitch, are you a member of our IGIC email list?
I am, and I just met with the working group with, get all of my notes, with Mr. Patrick Butler. Is that right? The GIO for Iowa?
Oh, Wilkie Brown. Patrick
yes.
Wilkie Brown.
Yep. And he was interested also in more improved communication with updates for LiDAR release. So I am connecting all the dots and making all the maps in the spreadsheets. So as soon as I find information, I will distribute that out to you all.
We have a IGIC business meeting and next month, Mitch, and that might be an excellent place to kind of tag a group of us for information and
okay.
So I might send you some information about that.
Sounds good.
Okay.
Good plan. Let me know and I'll put him on the agenda.
Perfect. That's Penny who just spoke up. I recognize her voice. She's our current chair of the IGIC organization.
And
trying to fly low under the radar here.
If you're software, not afraid of doing a little software development, there's a GeoJSON file that's updated every day with the footprints of data that's been released to the public data source. So if you go to that GitHub link that I sent, there's a GeoJSON file that's constructed every day there. And so you can grab kind of the current footprints that have made it through the process and been pushed up. And so that's one thing you could use as a service to kind of watch what might be made available. And also just to get kind of a footprint of everything.
Hey, Josh, I feel like I should know this, but when we send out things on the chat to everyone, does that show up with the recording, just like a transcript also?
Yeah, I believe so.
Okay, not the any private messages, but the public. So those links and things that got sent out will also be part of that recording after the fact. So
yes, I believe they will.
Okay. Does anyone else have any questions for Howard?
So this is Brian Gelder, and I do. So Howard, does the passing of Martin Eisenberg have any impact on your work at all? I know you guys have been moving away from some of the stuff that he had always done, but I didn't know if there's any future implications on any of that.
I mean, it's going to have an impact on a lot of people. It has an impact on a lot of people. I mean, his software tools kind of sit underneath a lot of things. You know, there's LiDAR processors that are using it to produce data. There are data warehouses that are using it to manage and provide data. LAZZIP sits underneath basically the entire industry as its compression technique. Although, you know, we know my team knows a lot about LAZZIP and can kind of do everything there. Yeah, it's really terrible that that happened, and you know, his impact is really large on the industry. His open source tools are available, and people can kind of remix them and do stuff that they want with them, given the license that's available. Not clear who the natural sort of heir to pick that stuff up is. Unclear what's going to happen with his commercial tools. I mean, there hasn't been any announcement or activity from that perspective yet. So, but yeah, it's going to have a lot of impact. I mean, he drove he drove a number of critical areas. He drove a lot of the LAS ASPR's LAS committee work. He was really instrumental in the development of LAS 1.4 and what we had developed there. Again, that was complementary to the LiDAR compression that was going on as well. So those worked together. But he was had a really large impact there. He also had a big impact on waveform LiDAR, which is very small subset, but there's groups doing various waveform stuff, and pulse wave was very impactful in how people did that. So yeah, it's been a really sad couple of weeks.
Anyone else?
Again, I posted my email in chat. I'm at Howard Butler on Twitter if you want to reach out to me that way. We have open source venues for all of this stuff. So, if you start digging in and get stuck or whatever, there's a mailing list you can reach out to. We're available for hire, even in Iowa. So if anybody wants to reach us that way, certainly we're interested in those kind of opportunities as well. And thank you for the opportunity and the new data that's coming on board for Iowa, having access to tools and capabilities to exploit it and do interesting stuff with it's going to be really important. And I hope you're able to do fun stuff with the LiDAR as it shows up.
And Howard, we're just really great. It's just great that we have such a resource in you and your company right here in Iowa. Processing, paying attention to all this stuff that a lot of us probably just have a very, very basic understanding, including myself for sure. I just want to let everyone know that we're going to be kind of continuing with this LiDAR theme. It must be LiDAR season. And next month, our Lunch and Learn for IGIC will be in October 27th. It's a week later than we typically have held it, I think, because the week before that, we have the IGIC business meeting. So we pushed it back a little bit. And Arthur Crawford with Esri is going to be talking about LiDAR, but really looking at different applications and using LiDAR. So it's kind of a nice follow-up with some of the tools that Esri provides and some of the applications that using LiDAR should be hopefully at least get the thoughts processing about how we can use this kind of information. So I'll be sending out information so everyone has the links and can get that on their calendar at this time. Thank you so much, Howard, for presenting, and I just always want to put that out there. We've got a couple things scheduled in the future, but I'm definitely entertaining some new topics. I'm interested in people who are interested in presenting, and if you have topics that you would like to see presented, suggestions would be great. Penny has got how to redistrict with the software the state will be supplying. That might be something we definitely need to topic. So anyway, if you have any of those, please email them to Penny Vossler or myself. I put my email in the chat, mcutler@cjaconsultants.com. And even if you just have a topic, we'll try really hard to find somebody that can speak on that topic. We're open to all kinds of suggestions, and we'll get a schedule out there pretty soon. And unless anyone else has anything they'd like to say, I thank you so much for joining us for this month's IGIC Lunch and Learn.
And thank you, Micah, for putting it all together. And thanks, Howard, for the entire presentation. It was great.
Great job, everyone.
Mm-hmm.
Everyone, enjoy the first day of fall.